Gloria Flora is the founder of Sustainable Attainable Solutions, an organization dedicated to the sustainability of public lands and of the plants, animals, and communities that depend on them. She's also the founder of the U.S. Biochar Initiative, and that is what she will be talking to us about today. Prior to this, she worked for 22 years with the U.S. Forest Service, serving in numerous posts. With that, I am pleased to introduce our next speaker, Gloria Flora.
Thank you very much, John, and your team for planning this and putting this together. It's always a huge work of dedication and attention. Are we going to provide what people are looking for? And how can we be most responsive to the crises that we're facing today? So today I want to talk to you about a subject near and dear to my heart, and that is biochar. So biochar is simply a fibrous material that is converted in a limited oxygen, high heat environment to create char or charcoal. The cool thing about charcoal is it's carbon. And when you put carbon in the soil in the form of charcoal, it lasts for hundreds to thousands of years. The charcoal that we find in the Amazonian jungle that I was just describing is actually 2,500 years old or more. And it's still doing all the positive things that we're going to get into to that soil and for the plants that grow out of that soil and the farmers and people that depend on the soil and those plants. It's doing the same thing that it did 2,500 years ago. It also can be a carbon negative or a carbon negative process. Now that's really unusual because when we have processes that create benefits like renewable energy, if we look at the components that are required to produce a solar panel, there's a whole lot of embedded energy in that from the mining, from the transportation, from the manufacturing. But biochar can be made in a way that is actually carbon neutral, meaning it sucks up and holds more carbon than it emits in the entire process, life cycle assessment process. Biochar has this wonderful capability of attracting and holding nutrients, water, but also carbon dioxide, nitrous oxide, and methane. And if you've been following climate science at all, you know that methane is 23 times more powerful in its effects than carbon dioxide, and nitrous oxide is 320 times more effective, or destructive, I should say, than carbon dioxide. So if you can have a natural material that can attract and hold these elements, you get all kinds of benefits. One, you don't get nutrient runoff, which is a real problem, which is why we have dead zones at the mouths of rivers, and why farmers have to keep applying and reapplying nutrients because they're running off, phosphorus and nitrogen in particular. Biochar will hold those, but in what's called loose covalent bonds, allowing them to be bioavailable to plants, but not letting them run freely. Next slide. Okay, let's take a closer look here. It's biochar, as I described earlier, it's charcoal, but charcoal with a purpose, and that is to either repopulate biology with nutrients or to protect biology from heavy metals and toxins. And one of the reasons it works so well is, check this out, that close-up microscopic picture of that. Look at the porosity. When we see that kind of porosity, we also have surface area. And surface area is where the action is. So if you have a positive or a negative charge, like the surface of charcoal pores has, it actually attracts positive electrons, like nutrients and water. So there's a really straightforward scientific explanation for why biochar works as well as it does. Next, you can have thousands of square yards of surface area in just a cubic centimeter of biochar. Next slide. Okay, how is this made? And okay, so here's our wonky slide. What we're doing at the far right, we're taking plant material that hopefully is not purpose grown. We're trying to be sustainable here, so we're using waste biomass, biomass that's excess to the forest and agricultural needs. So that waste biomass is converted through pyrolysis, which is a process of heat in a limited oxygen environment. And while it does release some of its carbon, 50% of the carbon in the original material is maintained within the biochar. The other materials that can come off of that, the byproducts, we'll get a little more deeply into that, can provide for energy, transportation, co-products, and other industrial uses. So let's go next slide. So how is biochar made? Well, there are a lot of different ways to make biochar. The one way that we don't make charcoal or biochar anymore or recommend against is in the upper right-hand corner there. That's the traditional method. That is, you ignite some materials and then you smother them and you let them smoke, which is a way of baking them essentially. But that creates a lot of smoke, and that smoke is valuable. There's important things in that smoke that can be used to aid in the combustion. So some of the ways that you can make it, very simply, the bottom right is a cone kiln, easy to do in your own backyard. Upper left is called a ring of fire, and it's a much larger container for limiting oxygen to a pile of forest slash or debris. And then there's industrial solutions, which are much more technical and expensive. But you can make char out of a pile of sticks on the ground. We call it conservation burning, as long as you top light it. Because when you top light it, the heat of the fire actually releases that smoke that we see, but what's in that smoke besides moisture is methane, hydrogen, carbon monoxide, all of those burn. And so what that top lighting is doing is sucking the smoke into the flames, burning it, and then being essentially smoke-free. So we've been working extensively with the Forest Service to encourage them to top light the slash piles that are out in the forest, because they're going to significantly reduce the smoke, and there's a possibility of creating biochar out of it. Now, you have to tend the pile if you really want biochar, but we'll get into that later, maybe. Next slide. Okay, products of pyrolysis. Obviously biochar, which is what we're talking about today, but you can also get bio-oil. There's actually a lot of oil in waste wood. The oil can be used as a bunker fuel in concrete plants and shipping. We don't recommend making biodiesel out of it. It's possible, but it also takes a lot more embedded energy to increase that the quality and the refining to biodiesel. Syngas can be a substitute for natural gas. It's lower BTUs, but it still can reduce some of the dependence on natural gas. Heat and power, we'll have an example of that a little later, and wood vinegar. Wood vinegar is fascinating material. It is very acidic. Used in high concentration, it is a pesticide. In moderate concentrations, it's an herbicide, and in low concentrations, it's a nutrient. How cool is that? We humans, though, define, just as we're wont to do, define certain things in ways that are convenient and meaningful to us. And what we define biomass is any based material, which when sufficiently dry can be thermally converted to energy and other byproducts. All very good, but that's not really all of what biomass is. Next slide. Nature says biomass is a complex structure of nutrients, moisture, and temperature regulators providing shelter, food, homes, and carbon sequestration. So who gets to use the biomass? Next slide. What we need to do is share, because all these ecological values that biomass has, we have to retain in the forest, or as you can see in the agricultural fields. If we remove all the biomass and think that we're going to do something clever like make biochar out of it, we are leaving that land prone to erosion, or we are removing habitat, we are removing feed for mycelium, or even feed for fires. As Jonathan rightly pointed out, fire has a very important role in ecosystems management and ecosystem structure. Next. So by taking the right amount, the waste amount of biochar and leaving sufficient on the, or biomass, and leaving sufficient amount on the land or in the forest, we actually find we have a lot of different resources that we can use for making biochar. So one is, starting at the bottom, animal residues. Yes, you can actually char carcasses. It's a pretty convenient way of getting rid of a lot of carcasses that you need to get rid of. They need to be dry. You can use algae or algae waste from algae oil production called digestase. If dried, you can use that. Industrial wastes, as long as they're clean, as long as they don't have toxins, residues, and other chemicals in them. Particularly preserved wood, the green wood, do not make biochar or attempt to make biochar out of that. It has chemicals in it that can kill animals, even as low as 5% by volume in a pile. So never try to use preserved wood for creating biochar. Our primary sources are urban wood waste and forest management wood waste. There are abundance. Actually, there is more urban wood waste created in the United States than the Forest Service produces in their timber management projects. You can use agricultural crops and residues, and not the crops you eat, but the residues from those crops. Corn stover, bagasse, what's left over from sugar cane, coconut hulls, nut hulls, anything that's carboniferous and not edible can be converted. Also, we don't want to use anything we can compost to make biochar. Compost has very important components to it. It's soft, it's wet. We don't want it in biochar, and composting doesn't want the dry, woody materials that we use for making biochar, so it's a nice fit. Biosolids, no. Sadly to say, we're all walking little hazmat sites, and we have forever chemicals in our bodies, and if you attempt to char biosolids, you will get forever chemicals, and those chemicals will stay in the soil and poison us and the plants and animals that depend on them. And also municipal solid waste. We can't sort it out to be clean enough to really trust it to make biomass or biochar. Next slide, please. All right, quickly, how much biomass do we have? Well, here's a study that the Department of Ecology did on a biomass inventory to see what we were really capable of. Were we to use that biomass for energy production or for biochar, other uses? So we have a lot of biomass available that's waste biomass. Biochar uses, oh yeah, putting the bio in the char. Let's go for it. Next slide. Okay, recap of some of the things that I've mentioned about biochar. Attracts and holds nutrients, attracts and holds water. This is critically important as we head into deeper and deeper mega droughts. Biochar can increase the water holding capacity of soil by 30%. Those of you who water your gardens or water your lawns, you know what what kind of difference 30% makes. So we're really encouraging the use of biochar in agricultural applications to reduce irrigation needs and still provide for the needs of the plants. Biochar has the ability to raise pH. So when we have really acidic soils, like we have in the Palouse from overuse of chemicals, you can really, instead of using lime, you can use biochar. Biochar improves the texture of soil, or tilth as we call it. It's really good in clay soils in particular because those little particles of biochar get in between the lenticels of clay that when they're dry they compact and make that almost impervious material. Biochar can prop those pores open. It increases the carbon, obviously, because it is carbon. It lowers greenhouse gases. It can reduce the off-gassing of nitrous oxide out of soils by 80%. We know for at least 3 years, because that's when the study stopped, but we believe it's going to be even longer. And also provides great habitat for microbes and for mycelia. Next slide, please. Here's the terra preta soil that I was talking about in the Amazonian jungle. Terra preta means dark soil. You can see that and I've been in soil pits in the Amazon that are 8 feet deep, and there's still biochar in the bottom of it. It was a religious experience, I have to admit. On the left-hand side, you see the dark soils, and on the right-hand side, the very iron-rich soils that are depleted of minerals or depleted of nutrients because of so much rain washing through the soil. So you add the biochar and you get this dark, rich soil. Here's another example in 20-centimeter increments, how you layer down and then suddenly find the place where where native soils start that hasn't been enhanced. Farmers in Brazil have told me that they pay 5 times more for land that has been treated with biochar than native soils. Next. Roots love biochar. This is a microscopic enhanced photo of root hairs wrapping around biochar. Why would that be? Well, because of the habitat I mentioned, the microbes and the bacteria that move into the pores of the biochar where they get protection and water and all the things that they need. It becomes a trading post because that bacteria and mycelia are trading nutrients and minerals to the roots in return for sugars and starches and the things that they like to eat. So they hide and the root hairs come over and have a party. Next slide. This is a really cool short video that starts at about 10,000 feet and zeroes in to biochar particles in the soil. And again, you see the root hairs, and these are actual photographs, and you see the bacteria and everything. So just trust me, it's really cool. So how does biochar enhance crop production? Well, here we go. In the upper corner is a cornfield in Colombia. With no biochar treatment, you can see what's on the extreme, your left, my right, whatever, way over. And then halfway, the moderate height corn has 8 tons per hectare. Hectare is about 2 acres. And then the sweet spot, which is about 20 tons per hectare, and the much taller corn. Same growing conditions, same soil, same treatment. That's the response difference in the soil. In the lower corner there, those are beans that are 5 weeks old. I don't know if you can see, but there's actually a little flip-flop, a gray flip-flop for size comparison. Again, same soil, same treatments. And this is a really interesting experiment here on bluegrass in Rockford, Washington, which is just south of Spokane here. In that area, the soils are very acidic. It's very typical to add lime, and so to enhance the growth of the bluegrass. So there were some biochar experiments done by the Agricultural Research Service in conjunction with the farmer. The control, you can see, one of the things I want to point out is also the paltry root growth. So, not very much above ground vegetation, paltry roots. If you just add lime, it really does help because it improves the pH and therefore the growth. But if you add biochar, you get this massive response because you're getting the liming effect, but you're also getting that nutrient and moisture boost as well. And that's again at 10 tons this is 10 tons per acre, which is equivalent to 20 tons per hectare. Next slide. Here's that same experiment showing you a little bit better how this, in a checkerboard pattern, which is a very wise way to do these experiments, you can see that the untreated is pretty slim growth. Liming does improve it, but the biochar is tall and lush. And the farmer invited me to go over there. He said, pick me up a handful of soil out of each of those plots. I went to the biochar plot, picked up a handful of soil, yay. Went to the lime-only plot, and I had to really dig my fingers in. It was starting to hurt to try to get some soil out. When I got to the untreated, I had to bang on it with my heel and I still couldn't get a handful of soil out of it. So there again, showing us that biochar improves soil tilth, the texture of the soil, the aerability within the soil. Next slide. You can use biochar in horticulture, and that is as a substitute for vermiculite. And the reason why this is really important is not only that you can make it yourself instead of depending on it being mined, but vermiculite is mined, and it's mined and found in conjunction with asbestos. I spent a lot of time in Libby, Montana, R.W. Grace vermiculite mine. Why did it close? Because it absolutely killed people with the asbestos. Asbestosis, over 220 people died in Libby as a result of asbestos exposure. So what was our response in the United States? It was like, okay, we'll ban mining vermiculite in the United States. We'll just get it from somewhere else. All those other people somewhere else, the brown people, the black people, they can mine it and get asbestosis, and we'll keep using it in our potting soil. So when you see all those little white things in your potting soil, don't be happy. That's vermiculite, and somebody might have paid with their life to get it to you. So let's use biochar instead of vermiculite. Next slide. I told you I'd preach. Okay, biochar and reclamation. Here's a beautiful example, and this is in the a watershed that feeds Aspen, Colorado, or supplies Aspen, Colorado with water. This is an abandoned mine. For 40 years, the Forest Service was unable to, since the mining company left, as they are wont to do, and left the cleanup to us, the public, the Forest Service tried to get that slope to revegetate, many slopes like that to revegetate, because it was continually eroding into the stream and eroding more than just sediment, but also toxins from the mine. With a set of experiments, they found that testing with untreated, with compost only, with a biochar compost blend at various percentages, they found that with a compost biochar blend at about 15% biochar in that blend, in a year, that site was rehabilitated, and no more erosion, soil growing, shrubs starting to come in. Truly amazing results. Next slide. Biochar is also used in remediation, as I've mentioned, acid mine drainage. It has a high pH. It can help ameliorate that acid. It uses a filtration. Stormwater remediation. How many people have been applauding and smiling at the beautiful the change in Country Homes Road? You know, it used to have a concrete swale down the middle of that divided road, and now it's vegetated. There's a lot of biochar in there. And what the city of Spokane has discovered is that it has reduced the amount of PCBs coming into their stormwater system by 90%. Thank biochar for that, and for the planners and the people who were foresighted enough to give it a try. Desalinization, biochar can also be used in that process, and increasing drought tolerance, as I mentioned before. Next slide, please. Biochar and livestock. Oh, I'm a farmer. I'm loving this. Biochar put in chicken litter will reduce the odors and the moisture in the chicken coop very significantly. If you raise chickens, you know that in the winter things can get stinky, a little moist in there, unpleasant, not with biochar. And what is happening is that as soon as my chickens see it, they eat it, which isn't a bad idea, because then they excrete it. That's mixed in with the litter, so my chicken litter is already charged with biochar. And charging, I want to mention that. Biochar in and of itself is not a nutrient. It is a soil amendment. Only when you charge it, that is, you add nutrients to it, does it become a fertilizer, or it acts as a fertilizer. So I'm charging my char by running it through my chickens and putting it in their coop. It makes their life happier, their stomach is happier, and likewise with ruminants. If you provide biochar by 1% volume in livestock feed of ruminants, it will reduce their methane output by 50%. That's a lot. And it makes the animals healthier. And I wondered about that. It's like, I read that, but, well, I had an ox Sadly, he died. But I had this beautiful, huge ox. And when I would make biochar, just in my conservation pile burns, he'd come right over as soon as it was cool and eat it. It was like, yes, I didn't even have to coax him. He loved it. Made him feel better. Next slide. Renewable energy. Okay, we're gonna pick up the pace because I'm not watching the time, and I could talk for a very long time, but I'll go faster. Renewable energy. Next slide. Okay, you can get heat, power, syngas, bio-oil, substitutes for fossil fuels, and put waste to use rather than storing it in a landfill or trying to figure out some other way to deal with it by making biochar. Next slide, please. Here's an ingenious little setup. There's a pyrolysis unit in the middle. Syngas is captured from that, converted to electricity, and fed back into the grid. The heat from the unit is fed into the greenhouse, and the biochar from the unit is used as a horticultural substrate. Full circle solution. Next slide. What about emissions? Well, especially in controlled pyrolysis, the University of Montana has a Biomass unit, which fits in it's a back of a semi, and they can pull up to a building, plug into their electrical system, fire up the biomass, the pyrolysis unit, and create energy. And they actually, at the University of Montana, do provide some of their own energy with their Biomass unit. It can travel around for demonstration, but one of the cool things is they have studied the emissions, and the emissions comply with the California Air Quality Standards Board, and California air quality standards are the highest in the nation. So we cover that. Next. Climate change, yes. Moving the carbon out of the active cycle. Okay, a simple definition of climate change is that you have the active carbon cycle, which has been going on since there were cellular plants. The biosphere stores carbon and releases carbon. We're part of that biosphere. That goes up into the atmosphere. The ocean helps us store carbon. The aquatic biomass takes that up. That's a very well-balanced system. But what we did was go to the inactive cycle, go to the stored carbon from fossil fuels, pull it up out of the lithosphere, and add it to the atmosphere and biosphere. We put the system out of balance and put more carbon dioxide in the system than the system was capable of ameliorating, neutralizing, or reducing and balancing out. It will eventually, but it will take many millennia after what we've done with the imbalancing and creating the imbalance in the active versus inactive cycle. Next. These are all items I've already mentioned, and so I'm just going to run through them really fast. Renewable energy, biochar can help with that. Soil amendment, persistent, it's less fertilizer, reduces water demand, improves water quality, filters out toxins, holds heavy metals, and raises the pH while increasing the moisture retention in the soil. And climate change, you're sequestering carbon, reducing the greenhouse gas emissions, and increasing plant growth, which also helps reduce the effects of climate change. Next. Oh, biochar and people. People are a part of the biosphere, atmosphere of nature. What is biochar doing for people? Well, when we introduce biochar practices, we are improving food security and crop yield. We are upcycling waste to a useful product, benefiting the local environment and the economy. We're designing, you can design and build your own equipment and create a business. And Eric will talk about that later this afternoon. It creates diverse local and entrepreneurial small business opportunities, as well as helping farmers, and you can market the technology and or the products. So we have a socioeconomic positive component here. Next. So in summary, biochar is really cool, and you get to play with matches. So there you go.